This video is about compound inequalities and absolute value inequalities. So when we talk about a compound inequality, we're talking about something with the words and or in them. And so before we talk about the mathematics behind it, let's just think about what it means to, in the English language, to have the word and or the word or. In order to talk about a compound inequality, we first need to talk about what the words and or mean in the English language and how that translates into mathematics. So let's just assume for a moment that I asked my best friend to bring me coffee and a donut. And just for the purposes of illustration, I'm going to put this on a number line. So let's just say that this is the area where I get my coffee. And this is the area where I get my donut. Well, when I ask my best friend for a coffee and a donut, that means I want both. And I get both in here where these two lines overlap. So in mathematics, when I'm looking for an and, I'm looking for the intersection of two pieces. So let's go back. Let's say I ask my friend for coffee or a donut. And again, for illustration, we'll put this on a number line. Let's say this is where I get my coffee. I'll be happy if I get coffee because I said coffee or donut. And this is when I get my donut over here. Well, I'm going to be happy in this region and also in this region. So when I'm talking about an or statement, I want anything that is shaded. They don't have to intersect. They might. That would be great. I would get both, but I only want one or the other. So let's look at that in terms of these inequalities. These are called compound inequalities because they're separated by the words either and or. And we'll take a look at this one first. Just solving the linear inequality. When we subtract 1, we get 3x greater than 3, and dividing by 3, x is greater than 1. On the number line, that's going to be here, greater than 1, open circle shaded to the right. This is like getting my coffee. Or if I subtract 5 on this one, I get x is greater than negative 2. So here's our negative 2. Greater than, so it's an open circle shaded to the right. And I want anything at all because it's an or statement. Anything at all that's shaded, so I'm going to be happy all of this time. So the interval notation here would be from -2 to infinity. So sometimes they overlap and sometimes they don't. In this case they did, but that really wasn't what I was looking for, and I know that because it was an or statement. Let's take a look at another one here. Solve 3x minus 1 less than or equal to 20, and, so I'm going to be looking for an intersection, 3x minus 1 is less than 5. So I'm going to start by adding 1. 3x is less than or equal to 21, or x is less than or equal to 7. So on my number line, here's 7, less than or equal to, so I'm going to color this one in. And then I'm going to solve this next one, add 1. 3x is less than 6, so x is less than 2. Oh, less than 2, not negative 2. So 1, 2, and it's strictly less than. And in this case, I want where they overlap because it's an and statement, and that's going to be in here. So that's going to be negative infinity up to 2 parentheses. This last one is slightly different. It doesn't actually have the word and or in it. It is an and statement. We call this a chain of inequalities because it's really minus 3x minus 1 is greater than 5, and also minus 3x minus 1 is less than or equal to 20. So it is an and statement, but we write it as a chain of inequalities. Now the nice thing about the chain of inequalities is we can just treat it like an equation, but rather than subtracting 1 or adding 1 to each side, we have to do it to each piece of the inequality. So in this particular case, I'm going to add 1 to each piece of the inequality. That's going to give me 6 is less than minus 3x is less than or equal to 21. I'm going to divide through by negative 3. Now, I'm dividing by a negative, so I have to remember to switch the direction of these signs. That's going to give me negative 2 greater than x greater than or equal to negative 7. Now, this example is interesting because basically on our number line, we're saying that x is between negative 7 and negative 2. The negative 2 is open and the negative 7 is solid. When we write our interval notation and we're using a chain of inequalities, it's very tempting to just write it in order of the inequality. But you'll notice in this case, when we read the graph from left to right, we always put the smaller number first. So this should be negative 7 to negative 2. All right, let's take a look at the next page here. These are absolute value inequalities. So an absolute value inequality actually translates into a compound inequality. You're either going to have an and statement, and that's true if you have a less than symbol when you start. That's how I remember that. Or you're going to have an or statement, and you're going to have that if you have a greater symbol when you originally start. So what we do in either case is we simply drop the absolute value, and then if it's an and statement, we're going to make it into a chain of inequalities, and if it's an or statement, we're going to separate them by the word or. So we're going to drop the absolute value, and we're going to either have the thing on the right being positive or negative. So let me give you an example. We first need to isolate the absolute value. The next thing we have to do is break it out of jail. That's what I say. Now, when you leave jail, you have an option to be good or bad. So that's how we're going to break this out. And then we're going to solve, and then we're going to give our answer in interval notation. So absolute value, you should be thinking of breaking it out of jail. So here we have this isolated already, and this is an great or, so this is an or statement. So we're going to have the word or, and it's important that we write that word because that's going to tell us if we're looking for the intersection or not. So the first time we're just going to drop the absolute value symbol and keep the 6 positive. And on the other one, we're going to drop the absolute value and switch the direction and the sign of the number on the right. So this is going to give me 4x is greater than 4, or x is greater than 1. This is going to give me 4x is less than negative 8, or x is less than negative 2. So let's take a look at this one on the number line. Here's 1, greater than 1, open circle, and less than negative 2, close circle. Now this is an or statement. So I don't care if I get both. I'm happy here, and I'm also happy over here. So the way we write this one in interval notation is negative infinity up to negative 2, union 1 to infinity. Let's do that again here. It's an absolute value inequality, so we're going to break it out of jail, but the first thing we have to do is isolate just the absolute value. So we're going to subtract 2 from each side and get the absolute value of 3x minus 1 is less than or equal to 4. So I've isolated it. Now I want to break it out of jail. 3x minus 1 less than or equal to 4. So I've dropped the absolute value and kept the 4. And we also get 3x minus 1 is greater than or equal to negative 4. So I need a word in here. This is a less than symbol when I started. So this is going to be an and statement. And the reason that's important is because now that tells me that I need to find the intersection of these two inequalities. So I'm going to add 1 here. 3x is less than or equal to 5, or x is less than or equal to 5/3. Excuse me. And then 3x is greater than or equal to negative 3, or greater than or equal to negative 1. So for this one on the number line, I've got greater than or equal to negative 1 and less than or equal to 5/3, which is a little less than 2. And because it's an and statement, I'm looking for the intersection, and my interval notation will be bracket -1, 2, bracket. So the one we just did, we made it an and statement, but we did not make it into a chain of inequalities. But we could have. So on this second one, or third one actually, let's use the chain of inequalities to simplify. So we know we have to drop this absolute value. And because it's a less than, we know it's an and statement, and we could write it as a chain. You cannot do that with an or statement. Basically, what we want to do is sandwich this between -6 and 6 and solve from there. So I'm going to subtract 2. -8 less than 5x less than 4. And then dividing through by 5 gives us -8/5 less than x is less than 4/5. And we notice that this is in order. The negative is on the left, the positive is on the right. It's just less than. We don't have that equal to. So our interval is going to be -8/5 to 4/5 parentheses. No need to draw the line graph because we can see already what the solution is going to be. Okay, I have one more example. This has a less than or equal to symbol. So that's going to be a less than. It's going to be an and statement. I can make that decision right away. But I can't break it up right away. I first need to isolate the absolute value. So we've got negative x plus 2 less than or equal to 9. Now it's an and statement. I can make this into a chain of inequalities and just sandwich it between 9 and negative 9. So I'm going to subtract 2, negative 11 less than or equal to negative x less than or equal to 7, and then divide by a negative. Oh, I'm dividing by a negative, so I have to switch the direction here. I'll get 11 is greater than or equal to x is greater than or equal to 7. So here's one of those situations where 11 is actually bigger than 7. And when we write our interval notation, we want the smaller number to be first. So it's going to be 7, 11. Brackets because we have these equal to bars. So we do have a few special cases, and that is when your number on the right is either negative or 0. And if we think about what absolute value is distance from 0. And we know when we take the distance, it's a positive value. That's why absolute value is always positive. So basically here we're saying we have a positive number greater than a negative number. And that is true all the time. So our solution is minus infinity to infinity. So I can use my reasoning skills to do that. But if I don't happen to notice that that's what's going on, I can go through the process. Greater than negative 6. This is an great OR, so it's an OR statement. 2x plus 5 is less than positive 6. This will give us 2x is greater than negative 11, or x is greater than negative 11 halves. And 2x is less than 1, x is less than 1 half. And if I graph this, negative 11 halves and 1 half, I'm greater than negative 11 halves. I'm less than 1 half. You'll notice that the entire number line is actually shaded, which is why we get the solution negative infinity to infinity. Now, let's look at this next example. I need to first, as I always do, get my absolute value all by itself. So in this particular case, I'm going to subtract 4, and I'm going to get the absolute value of 3x plus 1 is less than negative 2. So just reasoning through again, can we have a positive number less than a negative number? And the answer is no, and this has no solution. So again, I can reason through this, or I could break this up. 3x plus 1 less than negative 2, and 3x plus 1 is greater than positive 2. It's an and statement because of the original inequality, less than. And I'll solve. So 3x is less than minus 3. X is less than minus 1. over here I'll get 3x is greater than 1 or greater than a third. On the number line, if you're less than -1 and greater than 1/3, and it's an and statement, we're looking for the intersection and they don't intersect. So that's how we would know we have no solution. The last example here is an absolute value greater than 0. Again, is a positive number greater than 0 always? So the solution here would be -infinity to infinity. And similar to our first example, if we go through the process of solving it, we're going to notice that the entire number line is going to be shaded. That concludes this video. Thank you.